Hello everyone, so we're continuing the topic of BJTs. Previously we saw a BJT problem using an NPN transistor, and today we're going to look at another BJT circuit problem using a PNP transistor. So the question asks us to find the transistor parameters, and by that we mean finding I base, I collector, I emitter, voltage between base emitter and voltage between emitter to collector. And so I know that this is a PNP transistor by looking at this arrow here, because the arrow points toward inside the device. So I know that it's a PNP transistor. Compare it to an NPN transistor in which the arrow points outside of the base or outside of the device. So that's an NPN transistor. This is a PNP transistor. So first we need to label the terminals and then label the currents and voltages. So this is my emitter, the arrow is on the emitter, this is my collector, and this is my base. So I emitter enters the device, collector current leaves the device, and I base leaves the, let me plot it here. So this is my I base, and voltage between emitter to base, I'm going to label it here V sub EB, and voltage between emitter to collector, I'm going to label it here. So you don't need to worry about the base collector voltage, because using KVL you can write V sub BC in terms of emitter to base and emitter to collector voltages. So if you find only two of them, the third one you can calculate it. So we're looking for voltage of emitter to base and voltage of emitter to collector. Let me write the emitter to base KVL. That's gonna give me, this is my loop for base emitter, and this is my loop for emitter to collector KVL. So base emitter to base KVL tells me that 12 equals to V of emitter to base plus 40K multiplied by I of base plus 8 volts. Simplifying it is gonna give me 4 volts equals to voltage of emitter to base plus 40K multiplied by I base. Emitter to collector KVL tells me that 12 equals to VEC plus 1K multiplied by I collector. Now let's start by assuming that the transistor is off, or it is in the cutoff region, and find out if it is true or false. So I'm going to, by assuming that, assume the BJT is in cutoff. That means I base is equal to 0 and voltage of emitter to base is less than VD0, which is 0.7 volts. So from emitter to base KVL, I have 4 equals to V emitter to base plus 40K multiplied by 0, because I base is equal to 0. If you solve this one, VAB is going to be equal to 4 volts, which is greater than 0.7 volts. So the BJT is not in cutoff. Now that I know it's on, let's move on and assume that it's in active mode and test this assumption. Okay, so far I know that BJT is on. That means I base is greater than or equal to 0, and V emitter to base is equal to VD sub 0, and that's equal to 0.7 volts. So from emitter to base KVL, I can find the I base current. So I'm this emitter to base KVL, and emitter to base V sub EB, and from there 4 equals to 40K multiplied by I base plus 0.7 volts. From there I base is going to be equal to 82.5 microamps. This is greater than 0, that means the transistor is on, which we already found out here. Okay, so assuming that it's in active mode, then I'm going to have IC is equal to beta times I base, because this is the condition of the transistor being in and we're operating in the active mode, and voltage of emitter to collector, because this is a PNP transistor, so I'm going to use V sub EC. So emitter to collector is going to be greater than or equal to VD naught, which is 0.7 volts. Now I know the value of IB, so I can find the value of IC. That's going to be equal to, I know beta is equal to 100, it's the current gain. That's multiplied by 82.5 microamps. That's going to give me 8.25 milliamps. And from emitter to collector KVL, I can find voltage of emitter to KVL, V sub EC. So from this loop in here, I'm going to substitute IC for in the KVL and calculate VEC. I have 12 equals to V emitter to collector plus 10 to the power of 3 multiplied by 8.25, 10 to the power of negative 3. This is 8.25 milliamp, and this is the 1K resistor here. From there, voltage of emitter to collector is going to be 3.75 volts. So let's check if this calculated VEC is greater than VD naught. It's greater than 0.7. As a result, my assumption was correct.